So I wanted to take a minute and show you how to find the direction and the magnitude when you're given two vectors. Basically what you're being asked to do to start with, we need to make a vector that combines all the information that we're given. So in this particular example, we have two forces. We have a magnitude of 100 and 50 pounds. Those are two separate magnitudes, and they're acting on objects of 50 and 160. And this word respectively means that this 100 lines up with that 50, okay, and the 50 lines up with 160 degrees. So we can start by creating two vectors. So if I create, let's say I create vector v, and for vector v, I'm going to take that first, that 100, which is the force of the first vector, and I am going to create my vector. I'm going to multiply that 100 by the cosine of the angle, and that's going to give me the first coordinate of the vector, the first part of the vector, and then the sine of the angle. And this should look familiar, cosine, sine, because as you recall, when we create points, we always do the cosine first. The cosines are x, the sine is our y. So putting them in this order should be pretty straightforward. So what we're going to do here is we're going to multiply that out, and you can use a calculator to figure out that that makes this vector. If I do 100 times the cosine of 50 degrees, I get 64.28, and then I multiply the 100 times the sine of 50 degrees, and I get that the second part here should be 76.6. Okay, so there's my first vector where the force was with a magnitude was 100 and the angle was 50. We're going to do the same thing for the second part. I'm going to say that I have a magnitude of 50, and then I'm going to set it up the same way, cosine first, and my angle in this case is 160 degrees, and my sine second of 160 degrees. And that's going to give me, when I multiply all of that out, I get, for the cosine part, I get negative 46 and 98. And I highly recommend you go ahead and put these in your calculator as well, so that you can see how all of that, or make sure that you understand how that works, because taking a moment to do that will help you kind of solidify that information in your mind. Okay, so now I have my original two vectors. So what I need to do is I need to create a vector that combines v and w. So I'm going to create vector x, and vector x is going to be vector v plus vector w. So that means that I'm going to do the first vector, vector v, 64.28, 76.6, and I am going to add the other vector to that, the negative 46 and 98 hundredths and 17. And this is 0.10. I'm lazy and I don't bother writing the 0 at the end, but really this is 10 hundredths, which is just a tenth. All right, so I add these two together, and I end up getting that my vector x, which is what I'm going to work with for the rest of this problem, is 17 and 3/10 for the first part, because I just take and I add the 64 and 28 hundredths to the negative 46 and 98 hundredths. I get 17 and 3/10. And then for the second part, I add my, what you could call your y's, whatever it is you want to column I get 93 and 7/10. So now this is what I'm going to use to find the direction and the magnitude. So now, like, all we did here was we took our original two forces and we found the vector for the resulting force. So notice it says we're using 2 decimal places in all intermediate steps. Typically, we don't round until we get to the end, but when you see this, 2 decimal places, intermediate steps, you're rounding as you go. Okay, so this is the vector we're going to use to find that direction and magnitude. So the to find the direction, remember we just take the tangent of the angle, because the direction we're talking about is the angle, the tangent of that reference angle is equal to the y part over the x part, because remember we always do sine over cosine, y over x, however it is that you want to think about it. We get this, so then we say, okay, well that makes that reference angle, because we take the inverse tangent of both sides, makes that the inverse tangent of 93 and 7/10 over 17 and 3/10. And if you plug all that into your calculator, you should get that your reference angle is 79 and 54/100 degrees. So now we have our direction. We just need to find our magnitude. And remember, when we're doing magnitude, what we're doing is we're saying, okay, well the magnitude of my angle, that's what that these symbols mean. This is the magnitude of the angle, and I'm just going to use my distance formula on those two pieces. So the magnitude of my angle is going to be the 17 and 3/10 squared, and this should look like the Pythagorean theorem. It should look like the distance formula, because those two things are really the same thing. And so I just use that. That's the formula for magnitude, is the 17 and 3/10 squared plus the 93 and 7/10 squared. So that tells me, when I clean all that up, that my magnitude is 95 and 28/100. And that is my answer. So here is my magnitude, here is my direction, and I am done.